Hello everyone, welcome. Today I'm going to talk to you about the counter function that is coming from collections package again. We saw deck coming from collections package that enriched the list operations where we can extend, do the extend left and pop left as well as rotate. So today I'm going to introduce you the counter function, which is basically counts the occurrences of elements in a list. Okay, so let's jump in and see what it is all about. And as usual, I'm going to use this collection of references, and today I'm going to use quite a bit of information from docs.python.org. And also, as usual, I do this regularly. That the ipython.core.interactive shell, which gives me the ability to print multiple outputs from one cell. Okay, so I want to import collections, and then let's do the import collections as this is the previous part of the notes. I'm going to repeat that again. I talked to you about deck yesterday, so today let me talk to you about collections. So import collections, and from collections I'm going to import counter. Okay, so let me run this one and walk you through. So a counter tool is provided to support convenient and rapid computations of frequencies of values or strings. So this is a useful data science tool. Okay, this works with a list. So let's define a list. I'm going to define a list, CNT1, and I'm defining it as a counter, but nonetheless, I can use the for loop forward in this list. This is the list I'm going to use to show a simple example. This list has 6 elements, which is red, green, blue, blue. So there are 3 blues and 2 reds and 1 green. Okay, so that's the counter that we are going to make it, right? And you can use the for loop, forward in this list, and then count one, right? Count one word, whatever that word is. If it is red, it's going to plus 1 plus equal to 1, and if it is the next one, it comes, it is not. It is blue, it's not red, so it's going to add a new word blue to this, and then it is plus equal to 1, and when it reaches the third time red, it is going back to the red, and then it is adding plus equal to 1, so it becomes 2, and so on. Okay, and then I do the print CNT1, and then what is that CNT1 is, it's supposed to be red is it starts with red, right? So red is 2 and blue is 3 and green is 1. That's what it's supposed to print. On the other hand, I can do this simply using the counter function. Remember, it could be a, if for automation we may need certain simplifying functions. So here counter function can help that, and that's coming from collections package. So I do the same thing and then print CNT count 2, and then count 2 I should do here, count 2. So and then subsequently I'm running both, and to show you that actually in both the cases it is a counter, with blue is 3, red is 2, and green 1 is coming. But remember, if it is a complex collection of large collection of counting frequencies, the counter is very efficient. And so what I'm going to apply that for a very actual practical data analysis on text, basically. So I'm going to take Hamlet text, downloaded from somewhere in the internet, and I'm taking the Hamlet text, okay, that's available here in this directory, and I read that into Hamlet all words doc, okay, and then I use regex function. Slyly I'm bringing in now regex function into the fold, but just an introduction now, but I will give you a separate talk on that one, separate discussion or lecture on that one. So all the words I want to find out, all the words, regex dot find all, and I'm creating words from read from the words from which are alphanumeric. The words combination could the characters can be alphanumeric, and that's what this means. So read all the data, make all letters to lower cases. That's what I'm applying here. Read the document, convert it into words, and then I'll convert them into lower cases. Okay, that's what it is. And then I apply just counter for words. The words are counter H words here. I should be having H words. So here I have, I ran that, and then you can see that now count 1, CENT1 as well as CENT2 are having exactly the same representation, okay, and same values also. But counter is much faster, okay. So, and I would suggest definitely to use a counter to calculate frequencies. So blue is 3, frequency of blue is 3, frequency of 2 is red is 2, frequency of green is 1. For the Hamlet text, so we have a large collection of words. You see this one? Oh my, right? It's a big, huge document. So we have done it in no time, the frequency of the words, analysis of frequency of the words from Hamlet text. So I can just to see how the Word document turns out to be after I read it, okay, and that's what this one is basically. I can also get a specific word. There is something called get function. So I want to know how many C words is the counted words. So I have to go back to at the bottom. I should get it, but no, it is not there because I changed it in between. So I'm going to go to this one, okay, H words counts. I have to use that. So when I Hamlet all words document from and resulted for me Hamlet words counts, and then I want to just check how many frequencies of this particular word is there. That is use the function called get, okay. So I see it when I ran this, when I ran this one at the bottom I see 14, okay. And you could see that here also somewhere here, you'll see here the gentleman. So it's tough to search because it's such a large number of words, right? So I don't want to do that. So for maybe I can do me things, okay, because I searched that one. So let's go to me things. Oh, gentleman is here at the bottom. Yeah, that's why I tested that. So it is 14 occurrences are there. That's what it's picked up. So you can use the word if you want a very specific word. Then go use the function get. Now I want to read another document and see both are from Shakespeare. Hamlet is from Shakespeare, and also the book As You Like It is another drama is also from Shakespeare. So I just want to do a comparison between those two collection of words. That a simple exercise here. So I take the As You Like It text. I have that downloaded from MIT. So I read that document, read the document from that directory, and then I convert them all over after I find all the words. Finding all the words are accomplished by this one. This may still have some special characters and so on. For now, just I'm telling you that is considered as full word. Now, for that again, I do that. A words counts means As You Like It words counts. So I do that here. That's exactly what is. I can run it again, and it shows me this one. Now I want to do the most. We can do most common also. It's a very important thing, right? Most common 10 words. Let's say I have done it 100. The most common words from As You Like It are this. On the other hand, the most common words from let's say the Hamlet are the following. So I just have to put H words. Okay. So these are the two collections. Nowhere it compares, but these are some of the words are now I, of, is, in. All those things are it's not relevant words when you're doing really sophisticated word analysis. But I'm just telling you this is the most occurrence here. So but the is more here, but I is the most here. The is the most here, but nonetheless the is coming the next. But it's a shorter document. The As You Like It is a shorter document compared to this Hamlet. So that's why the frequencies are much higher there. So I want to introduce you some functions about how do we find this basically works like a list with the tuples, right? So how do we take two documents and then combine the documents in terms of the words? So you want to find out if you by putting together the two documents, you want to find out how many the's are there, how many ands are there in the combined collection of words. So that is done by what is called the plus function. Very simple, okay. you take the first document counter function from one, which is the first document, we can call it. D is that is called C. The D is the next counter object from another, that is called D. Now if you if you add plus, then it is adding the elements, corresponding elements frequencies are added. That's what it means. Okay, so we can see that momentarily for this top 10 we can count and see that the is becoming 1091 plus 695, which means 1609 1786. Remember that, we are going to compare the by doing this. So let's just complete this simple computation here. C minus D means you are subtracting the frequency values from the second document from the you subtracting the frequency values of second document from the first document. Okay, and the answer is here 2. This is answer is equal to A, because A is 3 here, B is 1, A is 1 here, B is 2. So the addition here, because it's addition here, you add A here, A here, that is 4, B here, B here, that is B equal to 3. The subtraction is that you remove the 1 from here, but you remove 2 from here. So this is going to be negative, but negative values will not be retained. Only counter is always about only positive values. Okay. And then C and ampersand D means the intersection, also called minimum values. So it is going to compare these two. If I do the C intersection these two, then it's going to say the is that this document counter, first document counter intersection of second document counter will give me the is 695, I is 633. Okay, so it is taking the minimum from here compared to this one, and it is taking the minimum from here compared to this document counter versus this document counter. That's what we are talking about. Okay, and I did do some kind of work here, and I also jumped in quickly. I wanted to see the certain frequencies and so on. I slyly introduced matplotlib here. Okay, so we'll see all matplotlib more in detail as a separate section, but you can do this kind of word analysis, or it doesn't matter. It doesn't have to be a frequent string based counting. It can be value based counting also. Okay, so thank you very much. Until I see you next time about chain map. Enjoy your day. Have a great, wonderful time. Be curious and be studious. Thank you.